Method number 5, sum or difference of two cubes. In this, we mainly follow the two identities, that is a cube plus b cube and a cube minus b cube. A cube plus b cube is a plus b bracket a square minus ab plus b square, and a cube minus b cube is a minus b bracket a square plus ab plus b square. Let's take an example. A cube plus 27b cube. So a cube plus 27b cube can be written as a the whole cube plus 27 into b cube can be written as 3b the whole cube, because 3 cube is 27 and b cube b cube. So this is of the form a cube plus b cube, the first identity. What is a? And what is b? 3b. So wherever there is a, you keep it a, and wherever there is b, you put 3b, right? So it will become a plus b, that is a plus 3b bracket a square minus ab, that is minus a into 3b, plus b square, that is plus 3b the whole square. So a plus 3b bracket a square minus 3ab plus 9b square. So that's your factorization, very simple. Let's do the second one. 16a raised to 4 plus 54a. 16a raised to 4 plus 54a. Now, out of these two terms, what is common? Because this is not of the form of sum or difference of two cubes. This is a raised to 4 and a. Of course, 16 and 54 are not perfect cubes. So what is common? In 16 and 54, 2 is common. In a raised to 4 and a is common. So what is left inside when you take out 2a as a common factor? 8a cube plus what if you take out 2a from 54a? 27. So 2a bracket 2a the whole cube plus 3 cube, right? So now it comes in the form of this in the bracket inside, which comes in the form of a cube plus b cube. So you can write it as 2a bracket a cube plus b cube is 2a plus 3, that is a plus b bracket a square, so 2a square minus ab minus 2a into 3 plus b square, and b is 3, so plus 3 square. So this will become 2a bracket 2a plus 3 bracket 4a square minus 6a plus 9. So 2a bracket 2a plus 3 bracket 4a square minus 6a plus 9. This is the complete factorization, right? The factor 2a is also out and everything is factorized. Let's take one more. A cube plus b cube plus a plus b. I can write it as a cube plus b cube in one bracket plus a plus b in another bracket. So what will a cube plus b cube become? A cube plus b cube will be a plus b bracket a square minus ab plus b square plus a plus b, right? So if a plus b comes out common, what will be left inside? A square minus ab plus b square plus, see, a plus b was common and taken out from both the terms. Now here there is nothing remaining. A plus b is outside. So what factor will be remain inside? Only one will remain inside. So a plus b bracket a square minus ab plus b square plus 1. Next question. 2a raised to 7 minus 128a. Now you must have understood that if there is something common, first take out common and then check which identity you can apply. So definitely 2a is common. A raised to 6 will be left inside, minus 64 will be left inside. Now can this be represented as perfect cube? But before it can be represented as perfect cube, I think you should write it like this: a cube the whole square minus 2 cube the whole square. A raised to 3 raised to 2, 3 2s are 6, 2 raised to 3 is 8, 8 square is 64, or 2 raised to 6 is 64. So a cube the whole square minus 2 cube the whole square. So this is first the difference of two squares. So this will be represented as 2a bracket a cube plus 2 cube and a cube minus 2 cube. 2a bracket a cube plus 2 cube, a cube minus 2 cube, that is a plus b, a minus b. So 2a bracket, what is a cube plus 2 cube? A cube plus 2 cube will be a plus 2 bracket a square minus 2a plus 4, one more bracket, it will be a minus 2 and inside will be a square plus 2a plus 4. So 2a bracket a plus 2, then a square minus 2a plus 4, then a minus 2 bracket a square minus 2a plus 4. So this is complete factorization of this term. Okay, next question. Let's take one more question. Okay, so the next question says that show that 15 cube minus 8 cube is divisible by 7. Show that 15 cube minus 8 cube is divisible by 7. So I will factorize 15 cube minus 8 cube. I will not find its value and show. So therefore 15 cube minus 8 cube I will factorize using a cube minus b cube. What is a cube minus b cube? A minus b bracket a square plus ab plus b square. Therefore 15 cube minus 8 cube is 15 minus 8 bracket 15 square plus 15 into 8 plus 8 square. So 15 minus 8 is 7 bracket 15 square is 225, 15 into 8 is 120 plus 8 square is 64. Now even if you don't add all of these in the bracket, you have already proved that 7 is their common factor. So definitely this number is divisible by 7. So you can prove, therefore directly you can write, therefore 15 cube minus 8 cube is divisible by 7. Even if you add and write the number as 7 into whatever number the sum comes, that is also fine. So if this kind of question comes, you have to solve in this manner. Okay, so I have completed this part. method number 5. Now there are some miscellaneous questions, and I'm going to include those miscellaneous questions in this part itself, so that we don't have to make one more video. Let's look at the miscellaneous questions. The first question. Now, whatever identities we have studied till now, you have to apply all or any of them. Okay, so the first question will be x square plus a square minus 1 the whole upon a into x minus 1. Okay, let's see how to do this. Can we write this as x square plus a square by a minus 1 by a the whole into x minus 1, which will become x square plus a square by a will become a minus 1 by a into x minus 1. Now what I'll do is I'll multiply this x inside. So x square plus ax minus x by a minus 1. And now I'll do grouping and taking out common. So this will become x bracket x plus a. Here what will remain here? So if I take x, so if I group these two together and I take out x common, here nothing common remains, right? Or else over here I have to take out, if I take out a as common, then okay, see this method. I'm not changing this, okay? Just see what I'm doing over here. Minus x by a minus a by a. I'm just changing this 1 into a by a. So by that, what will happen is x bracket x plus a minus, now what is common over here? 1 by a is common. Minus 1 by a is common. What will be left inside? X plus a. Now easily you can factorize x plus a bracket x minus 1 by a. X plus a bracket x minus 1 by a. Okay, next question is x raised to 4 plus y raised to 4 minus 23 x square y square. Now if you see the solution of this, I'm going to explain it to you. You will realize that we have done similar question earlier. See how I'm going to write. X raised to 4 plus y raised to 4 plus 2x raised to x square y square minus 25 x square y square. What I did is I split this minus 23 into plus 2 minus 25. And why did I do that? I did that because I wanted to complete the identity over here, that is a square plus b square plus 2ab. And here I got a perfect square. 25x square y square is a perfect square. It is a square of 5xy. So x square plus y square the whole square minus 5xy the whole square. Okay, so this becomes a plus b the whole square, and this becomes 5xy the whole square, that format. So a square minus b square, this is one term square minus second term square, difference of two squares. So this becomes a plus b and a minus b, x square plus y square plus 5xy, and x square plus y square minus 5xy. Let's do one more question. A square plus 1 by a square minus 18. This is also similar type like we just did now, very similar. Just see this. A square plus 1 by a square minus 2 minus 16. I split this 18 into minus 2 minus 16. Why? Because this looks very familiar to you. See, a square plus 1 by a square minus 2 minus 4 square. You know what is this? This is a formula. This is a formula for a minus 1 by a the whole square minus 4 square. So this is again difference of two squares. This can be written as a minus 1 by a plus 4 and a minus 1 by a minus 4. Right? So this is also solved. So these are the difficult factorizations which you will face in this chapter. Next question. A raised to 4 minus 7a square plus 1. Okay. So if you think that splitting the middle term is possible, it is not possible because the coefficient of a raised to 4 is 1 and the constant term is 1. 1 into 1 will give you 1 and the factor of 1 cannot give you minus 7. So splitting the middle term is not possible. What else is possible? Let's see. A raised to 4 plus 2a square plus 1 minus 9a square. So what I did is I split this middle term in such a way that I got 2a square over here and I got minus 9a square over here. Minus 9a square plus 2a square is minus 7a square. And here these three terms which I got over here, they are perfect square trinomial, that is in the form of a plus b the whole square, and this is a perfect square itself, that is 3a the whole square. So this can be written as a square the whole square plus 2 into a square into 1 plus 1 the whole square minus 3a the whole square. So a square plus 1 the whole square minus 3a the whole square. So this will become a square plus 1 plus 3a and a square plus 1 minus 3a. Right? So that's the answer. Let's go for one more factorization over here. A cube plus 3a square b plus 3ab square plus 2b cube. This is very easy. If you have done the expansion part properly, you would remember that this is of the form a plus b the whole cube. This is the identity of a plus b the whole cube. So how to apply this? See, a cube plus 3a square b plus 3ab square. Now we need b cube here, so we write b cube, but we have 2b cube, so we write plus b cube also. So plus b cube plus b cube 2 times. Now this thing is an identity. How to write that? So a cube plus b cube plus 3ab bracket a plus b. If you open the bracket, you get the same thing, plus b cube, and this is nothing but a plus b the whole cube plus b cube. Okay, so this is again in the form of a cube plus b cube. A cube plus b cube is a plus b, that is first term plus second term. So a plus b plus b, this is the first term plus the second term, bracket a square, that is a plus b the whole square, minus ab, that is b bracket a plus b plus b square. A square minus ab plus b square. So this will become a plus 2b. This will become a square plus 2ab plus b square. This will become minus ab minus b square plus b square. Minus b into a is minus ab, minus b into plus b minus b square. This minus b square plus b square will cut. So you will get a plus 2b a square. This plus 2ab minus ab will become ab. So a square plus ab plus b square. So a plus 2b bracket a square plus ab plus b square. This is the final factorization. The last question. A raised to 6 minus 26 a cube minus 27. Okay, now in this, if you see, splitting the middle term is possible in this. So if you want to do splitting the middle term, you can multiply minus 27 into the coefficient of a raised to 6. The coefficient of a raised to 6 is 1. So minus 27 into plus 1 is minus 27. And the factors of minus 27 from which you will get minus 26 is 27 ones are. So minus 26 you want. So minus 27 plus 1. Minus 27 plus 1 is minus 26. Minus 27 into plus 1 is minus 27. So a raised to 6 minus 27 a cube plus a cube minus 27. What is common? What is common? Okay, here a cube is common. What will be left inside? A cube minus 27 plus nothing is common, so 1 a cube minus 27. Right? I will write over here. There is no space. So is equal to a cube minus 27, which is common, and a cube plus 1. Now a cube minus 27 is nothing but a cube minus 3 cube bracket a cube plus 1. Now these plus 1 cube, okay, so these both brackets are in the form of a cube minus b cube and a cube plus b cube. Now what is a cube minus b cube? A cube minus b cube is a minus b bracket a square minus ab plus b square. B is 3, so 9. And a cube plus b cube is a plus b bracket a square. Some mistake I did here. A cube minus b cube is a square, a minus b bracket a square plus ab plus b square. And a cube plus b cube is a plus b bracket a square minus ab, a into 1, a plus b square, that is 1. So this is the final factorization. A minus 3, I'm writing b, actually it should be 3. A minus 3 bracket a square plus 3a plus 9 bracket a plus 1 bracket a square minus a plus 1. Okay, let's take few more questions, I think some more challenging ones. Suppose you've got a question in this form: 4x square plus 9y square plus 16z square plus 12xy minus 24yz minus 16xz, and they have asked you to factorize. What would you do? Now first you have to remember the identities which you have learned in part 3 of expansions. In part 3 of expansions, you learned identities which were of the form a plus b plus c the whole square. Can you see similarity of that type here? See, I will show you. If you write 2x the whole square, 3y the whole square, 4z the whole square. Now you must be wondering that why I have not put signs here. I have not put signs because of a specific reason, right? So okay, let me put signs so that you don't get confused here. And here I'm going to take out 2 common plus 2 bracket 12xy will be 6xy minus 12yz minus 8xz, right? So this is of the form a square plus b square plus c square plus 2 bracket ab plus bc plus ac. But of course there are some signs here and there which we are not able to understand. So can we rewrite this as now just I want you to observe the product of x and y terms, that is first 2 terms, is positive. So these 2 terms must be positive, and the product of y and z terms, that is second and third term, is negative. That means if this is positive, which is negative 4z. So you can write it as 2x the whole square plus 3y the whole square plus minus 4z the whole square. How did we come to the conclusion that this will be negative? Because the product of y and z terms is negative, the product of x and z terms is negative. So if a positive number is multiplied by a negative number, the answer will be negative. Positive number multiplied by negative, answer will be negative. But positive multiplied by positive, the answer will be positive, right? That's why I put minus 4z over here. So plus 2 bracket, now this is 6xy. Can I write it as 2x into 3y? Yes. Can I write it as plus 3y into minus 4z? Yes. And can I write the last term as plus 2x into minus 4z? Now check. Now check the form. The form is, what is the form here? A square plus b square minus c square plus 2 bracket ab plus bc, which will become minus bc because this is minus, plus ac, which will again become minus ac. So 4z is minus, that I know now. So this can be written as 2x plus 3y minus 4z the whole square. So this is nothing but, what we are doing here is doing reverse of what we have learned in expansions. In expansions, we learned to find the product, to expand something, to expand a bracket. But in factorization, we do reverse, we go backwards, right? So this is the final, you can say, answer of factorization of this type of question. We'll take one more type of question here. Okay, so the next question is 8a cube minus b cube minus 12a square b plus 6ab square. See how I will write it. 8a cube, I can write it as 2a the whole cube, minus b cube, I can write it as b cube, plus 12a square b plus 6ab square. What is common in these two? The common is minus 6 will come out, a square and a is common, b and b square, b is common, bracket. If 6ab comes out of this, what will remain inside? 2a, and okay, minus sign is gone out, so inside will be plus, and of course minus is gone out, this plus will become minus, and because 6ab has gone out, just b will remain inside. Can I write this as 2a the whole cube minus b the whole cube minus 3 into 2a into b bracket 2a minus b. Can you see I'm making everything fall in pieces in the form of identity? Which identity do you see here? A cube minus b cube minus 3ab bracket a minus b. It is nothing but a minus b the whole cube. That is the factorization, a minus b the whole cube. So this is also one type of factorization which you are going to come across. The next one is 27x cube plus y cube plus z cube minus 9xyz. You will be surprised when you see this factorization. This will be because we did the same identity in expansions. Factorization is nothing but the reverse of expansion. In expansion you expand, in factorization you factorize. That is, you again make them in the form of perfect square or perfect cube or the product of two brackets. So this will be 3x the whole cube plus y cube plus z cube minus 3x into y into z. So which identity we are going to use? Using this you will remember this identity using a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c bracket another bracket a square plus b square plus c square minus ab minus bc minus ac bracket close. You remember this identity from expansions? A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c bracket a square plus b square plus c square minus ab minus bc minus ac. So I have the form of a cube plus b cube plus c cube minus 3abc. I just need to factorize. So it will become 3x plus y plus z. So a cube plus b cube plus c cube, you can easily identify what is a, what is b, what is c. A is 3x, b is y and c is z. So it will become a plus b plus c, that is 3x plus y plus z. Second bracket, a square, that is 3x the whole square plus b square, that is y square plus z square minus ab. So 3x into y minus 3x into y minus bc, that is y into z minus ac, that is 3x into z. Right, just simplify this. So 3x plus y plus z bracket, this will become 9x square plus y square plus z square minus 3xy minus yz minus 3xz. So this is your final factorization of this type. Please, when you come across these kind of questions, don't get confused because we have already used this identity in expansion. This is a sort of revision for you, right? Let's do one more question. Okay, this is little different question, that's why I'm taking this. Give possible expressions for length and breadth of each of the following rectangles in which their areas are. Now the area is 25a square minus 35a plus 12, and you have to find the length of the rectangle and breadth of the rectangle. Now what is the formula for area of rectangle? Length into breadth. So this area, which is given in the form of a trinomial, a quadratic polynomial, you have to factorize that. You have to factorize that and express it in the form of product of two terms. So basically this is a trinomial which can be factorized only by splitting the middle term. Okay, so what is 25 into 12? 25 into 12 is 300 plus 300. 25 plus 25 into plus 12 is equal to plus 300, right? I will write them in brackets so you don't get confused. Plus 300 I have to factorize and get 35. Now this is a big factorization, right? So your tables should be very good for this. If your tables are not good, then you are going to struggle. Now I know that 15 twos are 30 and 15 into 20 is 300 and 15 plus 20 is 35. See, but I want minus 35, so both of these should be negative. Minus 15 minus 20 is minus 35 and minus 15 into minus 20 is plus 300. So I will rewrite this as area as 25a square minus 15a minus 20a plus 12. So 25a square minus 15a, what will be common between them? The common thing will be 5a. What will remain inside? 5a minus 3. What is common between these two? Minus 4. What will remain inside? 5a minus 3. Why minus? Because you have already taken out minus common. So minus will be remaining inside. So 5a minus 3 and 5a minus 4. So you have expressed area as the product of two terms. So therefore either the length is 5a minus 3 and breadth is 5a minus 4, or the length is 5a minus 4 and breadth is 5a minus 3. So any of the two possibilities can happen, right? So this is an application based question based on splitting the middle term. So I have almost covered all the types of problems of factorization, and the topic of factorization is over. Now you have to solve the remaining exercises, and if you have any doubts you can message me, right? So see you later in the next chapter's video. Bye bye.